One of the main focuses of secure communication is to leak little or no information to an eavesdropper. In some situations, perfect secrecy can be achieved, while in other situations, the best that can be hoped for is to maximize secrecy in some sense. For example, if a source of information needs to be transmitted, and the perfect secrecy capacity of a channel is too small, then we may be forced to transmit at a higher communication rate, which doesn't yield perfect secrecy. The traditional metric for secrecy in our research community is equivocation, which is the conditional entropy of the message or information source, given everything the eavesdropper knows. In contrast to this metric, we proposed a performance-based definition that relates to rate distortion theory. One implementation of this definition is a guarantee that any eavesdropper will experience a known level of distortion if they try to reconstruct the information signal. In previous work, we characterize optimal communication under this criterion in the basic setting. The results are most interesting in the causal disclosure case, where we assume that the eavesdropper has additional causal information about the signal. In this talk, we show that the traditional equivocation-based approach to secrecy and our proposed performance-based metric are not actually competing metrics for secrecy. In fact, equivocation can be viewed as one special case of the performance-based criterion. We use the log-loss distortion function to make this connection. So, the richer theory that comes from the performance-based, or if you will, distortion-based measure of secrecy, also characterizes equivocation as a special case. In fact, it's one of the most blunt special cases, as I'll demonstrate in the talk. Finally, to illustrate the concreteness of the connection between rate distortion theory for secrecy systems and equivocation, we'll also derive some statements not known in the literature about optimal equivocation in a point-to-point lossy compression setting. See you on Tuesday.